All right, here we are, back page of the 117 notes, and it says to sketch the graph, make sure we label the vertex, x-intercepts, y-intercepts, and line of symmetry. And since it's given to us in vertex form, we can find our vertex pretty quickly. It's going to be at 1, 5. 1, 5 is our vertex. 1, 5 here. Which means our axis of symmetry is x equals 1. It goes right through that vertex. X equals 1. That's our axis of symmetry. Okay. And again, here's our vertex. And we know it's going to open downward because it's a -2, and so that can be a helpful little tool for us. As we're finding the y-intercepts, you might be tempted to just say that it's 5, but make sure you pause for a moment and consider, where do I have y-intercepts? Well, I have them when x is 0. So let's see what we actually get. We have y equals -2 times, and I'm going to plug in 0 for x. So 0 minus 1. 0 minus 1 squared plus 5. Well, 0 minus 1 is -1, and -1 squared is +1, and +1 times -2 is -2, and -2 plus 5 is 3. So our y-intercept is at 0, 3, not at 0, 5. So be careful about that. You'll be tempted to just to assume that it's 5 right there, but please be careful. Now we also know this point because it's reflected across the axis of symmetry. So just this one is our y-intercept. The other one's just a reflected point. We don't need to label that. And I'm not going to find your x intercepts right now. We've done that quite a few times. You'll go ahead and just use your quadratic formula, plug all your a, b, and c values in, and you'll find them. But here on your graph is where they are at. So here's an x-intercept, and here's your other one. And they're both real. Neither of them are imaginary. We're all good to go. Now on the other problem here, and actually let me go and make the page a little bit bigger. Okay, now we have some working room here. It's given to us in standard form, and you could do x equals -b over 2a and get to your axis of symmetry pretty quickly. So -2, so x equals -2 over 2 times a, which is 1/2. And so you would 1/2 times 2 is 1, and so you'd find out pretty quickly that x is equal to 2. But let's use this as an opportunity to review again. I'm changing it to transitional form, to vertex form. So if I have y equals 1/2 times x squared minus 2x, and I'm going to leave that gap here, plus 4. Remember, to switch to transitional form or to vertex form, we need to complete the square. So I want that gap open for me. Now y equals, and I'm going to factor out a 1/2 right now, so 1/2 times x squared, and if I factor out a 1/2 from -2, that gives me -4 and -4x, leaving that space open still, and plus 4. Now what number is it that's going to go here? Well, I'm going to divide -4 in half and get -2. -2 squared is plus 4. Now I didn't actually add 4 to this side over here. I added 1/2 times 4, which is 2. And to keep that balance on the right side of the equation, if I just added 2, then I need to also subtract 2. All right, now we're ready to change it into transitional form, and that's y equals 1/2, or vertex form. That's y equals 1/2 times x minus 2 squared plus 2. And so 4 minus 2 is positive 2. And our vertex is at HV, or HK, whichever one you're more comfortable and familiar with. So our vertex is at 2, which makes sense. We already saw that the axis of symmetry should be at 2. 2, 2. There's our vertex. 2, 2. Now it's a positive a value, and so hopefully we can see that it's going to be opening upward. Here's our axis of symmetry. That's one of the things we're supposed to have labeled here. So x equals 2. That is our axis of symmetry. Our y-intercept happens when x is 0, and so 0 squared minus 2 times 0 is 0, plus 4. It is the number at the end when it's in standard form. So 0, 4. Just don't assume it when it's in vertex form that number added at the end is still it, because clearly 2 is not our y-intercept right now. And these two equations are the same thing. They're equivalent to each other. They're just in some different forms. But other than that, they're the exact same thing. And so here's our graph, just sketching out a parabola. So we were supposed to label our axis of symmetry. Here's our vertex. Here's our y-intercept. And this time we do not have any x-intercepts. No x-intercept. And because our roots are imaginary. Imaginary roots. Remember we talked about when the graph is opening above, when the parabola itself is above the x-axis and it's opening upward, our roots are imaginary. When our vertex is below the x-axis and it's opening downward, again, our roots are imaginary. The parabola never touches the x-axis, and so we end up with imaginary roots, or no x-intercepts. All right, hope that helped.